Let's take a look at the HAC anchor channel from Hilti. So firstly, simple description of the channel product. We have obviously it's made up of the channel form, headed studs or anchorage feet of various lengths as specified. Importantly, we have a foam insert inside the profile of the channel which prevents the ingress of concrete during concrete pour, etc. We have a tear strip. So the strip here is available to us to help us pull out the foam once we strip the form from our concrete construction and want to get the foam out to put the T-bolt in. Additionally, we have end caps available to us, again, to further prevent ingress of concrete. Now, important to recognise with any of the channel systems that they are indeed a system. So the channel that we have here will be working with an appropriate T-bolt, a matching T-bolt. So it's very important to refer back to the documentation available with the product to make sure that the T-bolts being used are applicable to the channel that's being used. Now, typical applications which we have a plain style channel with a plain T-bolt will give us resistance to loads in basically two orientations. First, tensile loads acting in the plane of the axis of the bolt. So that's loads acting in this direction. The other basic operation or direction of load case that will be resisted is that of shear perpendicular to the axis of the channel. So the shear acting in this direction will be resisted by the bolt, the T-bolt in the channel, bearing against the channel. As you can see, in a plain configuration with a plain T-bolt and plain channel, that T-bolt will be free to move longitudinally in the axis of the channel. So no shear resistance in that regard, apart from what's available through clamp. So in order to accommodate shear loads in the axis of the channel, the Hilti hack system comes with a toothed T-bolt. So that's a T-bolt which has a mechanism in the coupling piece here in the T-bolt which interacts with the channel lip and engages with it such that it is then able to resist shear loads in this direction. Taking a look at our typical applications. So for channel installation, first thing we need to do, we need to verify that the correct channel is being used and the length is correct. So the channel details will be available on the product body. Make sure that's correct before we put it in our formwork. Make sure we have our instructions for use available so that we know exactly what's required of us there. Importantly, because we are doing cast in, we only get one shot at positioning the product correctly within the formwork. So make sure our dimensions are correct, that the product is positioned in the form in accordance with the documentation for the project. Again, before placing it in the form, check the foam. Check the integrity of the foam insert. The foam insert is what will prevent the ingress of concrete into the section during the concrete pour and allow us later to easily interact our T-bolts in that T-bolt, in that channel section. Additionally, with some applications, there may be a requirement for additional supplementary reinforcement called up with the documentation for the project. It's important to make sure that goes in at the same time. Now, the required items for installation, obviously we need the channel as specified. We'll need a tape measure to help us correctly identify the location of the channel in our formwork. We need nails for near far face application. So if we're doing far face application of the channel, we want to nail it down into the timber form. We'll need a hammer for driving. So in terms of that far face application, if this was our far form, we're just applying an appropriate size nail In this case we're using clouts because they have a large enough head to not pull through the holes in the channel. Position, and we simply nail those into the channel with our hammer and we're good to go. In terms of near face installation, that can be a little trickier. So obviously what we want to do is we want to position the surface of the channel either flush with the level of the concrete, if that's our intention, is to get a flush surface finish. In order to achieve that, if we're mounting, for example, on top of a top mat of reinforcement, if, for example, we had a cover height to our reinforcement that was the same height as the section of our channel, we could potentially simply lay this on top of our top mat of reinforcement, tie wire it down into position, and we'd be able to finish our concrete to the top of the channel. We'd be good to go. For applications where we want to have our channel recessed below the surface of the concrete, we would typically make use of a template. So that's simply a form board. We fix the channel to the form board and then we mount the form board in and about the formwork on top of the existing top layer of reinforcement, etc., with additional bars, or do what we have to do to get that height positioned correctly in the concrete for our finished application. You'll notice we've cut some additional holes into the template. That's potentially going to become an issue for us and something we want to do in bigger pieces of form where we don't want to suffer from air entrapment in and around the base of the channel after vibration. These allow the air bubbles to come out and make sure that we get good compaction about the channel and about the feet of the headed studs. So in terms of side fixing the channel as well, sometimes we want to come in and side fix to form. Assuming that was the side form, we'd simply come along as we do for fixing downhand to a far face application, 2 nails in through the nail holes in this case, and fix it at the correct height. Now, one of the very important things for installation of channel is that of concrete placement. So apart from getting the channel correctly positioned in the form so that we meet with the specification documentation, we want to achieve good compaction and vibration of the concrete around the channel. So the performance of the channel to resist the loads applied all comes from the feet and the concrete around the feet. So we want to make sure we get good compaction and vibration around the feet in both locations, in all locations, and along the channel. One of the important things for us with regard to positioning of the channel and adjustment is if we do have channel which ends up protruding from the surface of the concrete, we need to be very careful that if we want to readjust it to get it flush with the finished level, that we recompact around the foot of the insert. So if we wet adjust and we don't recompact, what happens is we push the concrete away with the foot and we end up with a void occurring around the foot of the insert. And this is going to result in a reduction in performance of the channel for pull-out loads, etc. If it's required that channel be cut to suit the size of formwork that we're fixing into, it's important to note that most channel comes with restrictions on the proximity of that cut to the headed inserts. Now in this case, for this particular model, we have a minimum distance of 25 millimeters away from the headed stud to where we can cut the channel. Now that we've discussed installation of channel into far face and near face applications, we'll go ahead and do a edge form installation in this formwork. In this particular case, we have a 40 millimeter channel section and we've got markings ruled out to give us a channel height that's centered on the height of the form. We have a 200 millimeter form, 1.2 meters wide. Obviously, before we place the channel, we want to check our dimensions and make sure we're going to be in the right spot. Let's just do a final check of 80 millimeter height, which gives us the channel centered in the section. And for a 300mm length of channel. We're going to need a 450 edge distance to our marking, which we do there. All right, so our markings are good. If we line up with those, we'll get a good outcome once we have the product cast into concrete. Let's go ahead and position the product. Line it up with the lines, line it up with the edge marking to centre us side to side. Nail the cleats in. Now ideally when we're doing this in a full application, we'd want to do that with the cage not in the form already. In this case, it's quite small, it's easy to get to, so we'll do it this way. Prior to the concrete pour, a couple of last things to check. Just make sure that the product hasn't been displaced prior to pour by foot trafficking, getting knocked by other trades or other equipment. And that way we'll be sure to have a good outcome when we go to strip the form later. That's our edge form channel installation. What we'll do next is we'll move over to our formwork, which we will strip to expose our channel that we placed a couple of days ago in the concrete pour, and we'll take a look at all of the steps required to strip out the foam, make sure we're using the right T-bolt, get that T-bolt orientation correct in the channel, and fix down a fixture plate. Let's take a look now at the process for stripping our form, exposing our channel, and then preparing our channel for installation of T-bolts and subsequent installation of a fixture plate. So we've stripped the other sides of the form, which should make it easier for us to get access to this face. Come in the side here and remove the side form. Place this over here. And there we have the channel exposed on the face there. Might just strip this fillet out, which will take some of that other material out as well. Just give us access to that and give us a nice clean front face to work with. All right. So there's our channel section in there. As you can see, obviously we've got the protruding heads of the nails, so be careful of those when stripping. We'll knock those back in later to get them out of the way. As you can see, we've gotten a very good finish here with the channel mounted flush to the surface of the form. So we haven't had any problem of the channel becoming dislodged either during foot trafficking of the reinforcement or subsequent vibration with a poker vibrator. That's a really good outcome for us. One of the benefits here with the Hilti foam insert in the HAC channel is the tear strip that's used to remove the foam from the channel. So we'll just get a hold of that tear strip and we should be able to use it to, without pliers, we should be able to use it to help pull the foam from the section. Get another grab of it, and there it is. So there's the foam. That's come out in one piece nice and easily, so that was a good removal. And obviously now what we've got exposed is the channel ready for cooperation with the T-bolts. First thing we'll do, just as a safety point of view, we'll just knock these nails back, knock them away from where we're going to be installing the T-bolts. That way we don't run any risk of knocking ourselves on those. So I'll just give them a nudge. One there, and that one there. Excellent. Now, having reviewed back with the information for the product, the installation instructions, we've determined that the appropriate T-bolt for use with this channel is this particular one here. So this is an M16 T-bolt. It will turn in, it turns in one way obviously, it's tapered to turn in one way. We can get one T-bolt in. Let's run the nut and washer off the other. And get our next T-bolt in. Now importantly, when setting up our T-bolts in the channel, to make sure that they are in correct orientation to take load, what we want to see is we want to see the line, the screwdriver slot as it were, in the back of the channel, the T-bolt head. We want that to be perpendicular to the plane of the channel. So in this case, horizontal channel, we want vertical lines on the front of our T-bolts. Having confirmed that this is the correct channel for these T-bolts, and we can additionally check the channel later by way of the product information inside the channel, printed inside the channel. We can then go ahead and apply our fixture plate. So in this particular case, we would come in, fix our plate, run our washers on. Let's get that nut started. There we go. Get one of them started so that we can get that in place. Now obviously that's turned while I was adjusting it, so that's not correctly set. Back it off, turn it so the slot is perpendicular to the axis of the channel. Tighten it up by hand just to give us something to work with, then we can go ahead and do the second fixing. Apply the second one, perfect. Again, must be certain that when we do go to torque up this T-bolt that our marker, our indicator in the head of the T-bolt is perpendicular to the axis of the channel. And there we have it. Obviously we would need to get this positioned correctly in accordance with the design information. And then importantly, we utilise an appropriately set torque wrench to apply the appropriate torque to these bolts. So let's do that now, get this plate set up. Just come through nice and easily. Get both of those ready and get to the desired torque value. There's the indication noise suggesting we've reached torque. Reset the torque wrench. Back on the second bolt. And there's the indication noise. Two correctly set T-bolts, correct alignment, demonstrating that they've been installed correctly. Lovely finish on the channel, flush with the face of the concrete. That's the Hilti HAC channel installation.